Example number 3. Turn to example number 3. 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 We there? Are we there? Are we there? Are we there? Are we there? Okay. If I have just the radican there, we call it square root, right? If I have just a radical there. If I have radical 4, we take the square root, right? You know how we have like a number that if it has an exponent of 1, we normally don't put the 1 there. Well, it's the same concept with this radical, okay? If we don't have a number inside the square root, it's actually a radical. It's 2, okay? We just normally don't put it there. It's like 4 to the first power. We know it's to the first power, but we just don't put it in there. So that when you do take the square root of 4, that equals plus or minus 2. Okay? Yes, sir.
Next time you take part of the break,
what's your question? Yeah. Let's finish up the math thing, then we'll go to this. He's a famous, very famous physicist. Yeah, he died today. Okay, so what we're actually doing here, see if you can follow, okay? And we did this a little bit a couple days ago. We're actually taking the square root of 2 squared. This radical cancels out the power of 2. That's why I end up with that 2. Okay? That's what that symbol means. So, remember that the square root or radical cancels out the power of 2. Now, with variables, we're going to not only simplify the numbers, but we're going to simplify the variables too. Okay? So let's do our perfect radical, right? And then our imperfect radical. And again, remember that it's a 2 there. Okay? 32. Now, Mr. Chambers went to go get your perfect squares, but they're up on the board over there. Remember how to do this, how to simplify numbers. You take 32 and you find the largest perfect square that's a factor of 32. If you do the calculator method that I showed you, what you do is you take 32, let's see, you could divide it by 2 and start with, in fact, 16 is a perfect square, so we happen to get lucky. So 16 and 2 are my factors of 32, with 16 being the largest perfect square. Okay? Now, r squared. R squared in itself is what? It's a perfect square, right? R squared. K to the 4th is 2 perfect squares. So I'm going to put k to the 4th under the perfect square radical. What about t to the 5th? Well, t to the 5th is not a perfect square. Okay? But t to the 4th is. So I'm going to put t to the 4th underneath my perfect square radical. But then I'm going to have to put, since I only used up 4 of them, I'm going to have a t to the 1st extra. So that's going to go in my imperfect one. Okay. Now, let's go back and take the square root of all these. What's the square root of 16? Square root of 16. It's up on the board. 16. 4. Okay. My 2 divided by 2 gives me 1r. What's 4 divided by 2? What's 4 divided by 2? 2, right? And my t, I'm going to have 4 divided by 2, which is 2. Right? And then I have this left over, 2t. That's my answer. Easy peasy, right? Should we do another one? Of course we should. Alright. Square root of 56, x to the first, y to the 10th, z to the 5th. I'm going to need my perfect radical, my imperfect radical. Okay, 56. Well, let's do our calculated method. 56 divided by 2. I'm going to start with the largest perfect square under 28. And that would be, looking at the board, is 25. So I'm going to take 56 divided by 25, and I get a decimal. So that's not going to work. The next perfect square would be 16. 6 divided by 16, 3.5. Decimal, that's not going to work. I'm going to use 9 as the next one. 56 divided by 9. Nope, decimal. And the last one, better work, divided by 4 equals 14. So, oh,
They go, don't say we cut them, because I did it fast, and a couple of times I used too many.
I always screw that thing up and I sit there and start swearing.
I even picked up some of the paper and fell on the floor.
Here, you guys want it, you want these?
Yeah.
All right, so my perfect square is 4, and my non-perfect square factor is 14. With me? You with me? You with me? Okay, x to the first. Do I have a perfect square in there? X to the first. No, because if I took 1 divided by 2, I would get a decimal. So my x to the first goes over in the imperfect radical. How about y to the 10th? If I take 10 divided by 2, do I get a whole number? Yes. And I'm going to use all 10 of them. Okay. Comes out to y to the 5th. What about z to the 5th? Remember, I'm dividing by 2. Well, the only way I can do it is if I have 4 of them, divide by 2, that'll give me an even number. But I'm going to have 1 left over. So I'm going to put it in the imperfect radical. This is actually one of the harder things we do in Algebra 1. Thank you, sir. All right, so the square root of 4 is 2. 10 divided by 2 is 5. 4 divided by 2 is 2. And I have left over 14xz. That's my answer. So easy, I almost a caveman can do it. I'm ashamed to assign them to you. Questions on square rooting variables, simplifying? Okay. So let's take a look at your homework then. 9.1 sheet. Let's see if we can't wrap that one up. Do we have any variables on this one? Nope. All right, let's look at some addition and subtraction. Since there's no variables, why I just lectured on it, I don't know. Let's look at some addition and subtraction ones, okay? We know how to do multiplication. Just like fractions, they have to have like the same radical. Fractions have to have the same denominator in order for us to add or subtract them. If they have the same number underneath the radical, then we're good to go. Okay, number 10. You guys back to your worksheet? Back to your worksheet? Worksheets? Worksheets? Worksheet? Worksheet? Worksheets? Worksheets? Back to worksheets. We're doing our worksheets right now.
You're not doing your worksheet, bro? Oh,
Do you have your worksheet out?
yeah. What are you doing, man?
Okay, let's look at number 10. Number 10, I have the same radical, so therefore I can go ahead and do the addition. 2 radical 7 plus 3 radical 7 is, that's right, 5 radical 7. Think of them as like terms. Number 11, 3 radical 15 plus 5 radical 15. 8 radical 15. Good. How about 13? Well, here I have 2 radical 6's, right? So 2 radical 6 plus 4 radical 6 is 6 radical 6. And it says I have to minus 3 radical 7. Can I do that? No, because this is like adding 6x and minusing 3y. Okay, these are different radicals. This is it. This is my answer. I can't go any further. How about number 14? Can I subtract those? If it was multiplication, I can go ahead and multiply. Just like fractions, we don't really need a common denominator. We just multiply across, right? But with radicals, same thing with fractions, addition and subtraction, you have to have a common denominator. So here I have to have a common radical. I don't have one here. I can't simplify radical 21 to get radical 3. So I'm done. I can't, there's nothing there I can do. Okay. What about 15? Can I add those together? Well, maybe, because I know the 18 and 32 can be simplified. So we're going to have to simplify both of those. So let's simplify the first term. I got my 2. What's the largest perfect square that's a factor of 18? 9. I'm going to have the square root of 9 times the square root of 2. Okay. So I have 2 times the square root of 9 is 3 times the square root of 2, which is 6 square root of 2. I'm going to bring down my plus sign. Now I have to simplify square root of 32. Again, I'm going to have to make a perfect and imperfect square root. What's the largest perfect square that's a factor of 32? 16. We just did this, didn't we? 16 times 2. And what's the square root of 16? So I have 6 radical 2 plus 4 radical 2. Hence, I can add these because now I have the same radical. 6 plus 4 is 10. Leave the radical 2. Algebra 1. Yeah, they go over it again in algebra 2 because, yeah. Comments, concerns on addition? So with addition and subtraction, you have to simplify before you add or subtract. It's the opposite with multiplication and division. Okay, you go ahead and divide, and then you simplify or multiply. Okay, let's do another one of those. Those were so much fun. I want to do another one. 16. I can't add them like they are, but I can simplify these. Okay, I have my 5 that's out in front times perfect square, imperfect square. What's the largest perfect square that's a factor of 8? Anyone? 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 Bueller? Bueller? How could 10 be a factor of 8 when it's less than 10? No, because you guys are just throwing numbers out there just to be funny. Okay, what are factors of 8? 4 and 2. Thank you from the peanut gallery. Okay. 5. What's the square root of 4? Anyone? Anyone? 2. And then I have square root of 2 left over. Just spit it out as it comes to you, okay? 5 times 2 is 10. Radical 2. Bring down, in this case, a plus sign. Now we have to simplify 50. So I got my 7. I'm going to have my perfect radical and my imperfect. What's the largest perfect square that's a factor of 50? You guys are going to do so well on the quizzes. Anyone? Anyone? Bueller. 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 How about 25 times 2? Now that you have those little yellow charts in front of you.
Yep, face forward. Pick up that phone.
Okay, so this is 7 times square root of 25 is 5 times square root of 2. 7 times 5 is 35. Square root of 2. 10, now that I have the same radical, I can add them. 10 square root of 2 plus 35 square root of 2 is 45 square root of 2. Now addition is different than multiplication, right? Number 20, this just means radical 15 times radical 15, right? With multiplication, I don't have to worry about having the same radical. This one does. Just go ahead and multiply and take the square root. Okay? You guys remember division? You could split this, you could do this one of two ways. You could split it up, square root of 25 over square root of 49. Square root of 25 is what, Dewey?
5.
And square root of 49?
7.
18, what's the square root of 1?
1.
Square root of 169.
50. No.
Look at your card. Okay, here's my squared, perfect squares. I'm looking for 169.
So, yeah.
13. There you go.
Yeah. It is.
In fact, you should have this right in front of you. 19, square root of 36 over square root of 48. Oh, this is one of those fun ones. Ooh, let's do this one. Square root of 36 divided by square root of 48. Okay, square root of 36, well, I look at my card here. 36, it's right there. So it's 6. Square root of 48. Don't have a 48. So I'm going to have to do what? That's right, simplify it. Put it into a perfect square and a non-perfect square. See, the largest perfect square that's a factor, 48, is well, let's use our calculator method. 48 divided by 2 is 24. So the largest perfect square less than 24 is, let's see, I look on my chart, 16. So I'm going to take 48 divided by 16, get a whole number. So 16 times 3. So 48 can be written as, what's the square root of 16? 4.
Yeah.
Radical 3. Now, what's that rule about having radicals in the denominator? That's right. We can't have radicals in our denominator. So, I'm going to multiply it by what's underneath the radical, which happens to be 3. So I'm going to multiply it by radical 3 over radical 3. You with me? Dewey? Pascal, with me? Okay, 6 times radical 3 is 6 radical 3. 4 radical 3 times radical 3. Well, if I do it in my head, it's 4 times radical 9. Radical 9 is 3, so I got 4 times 3, which is 12. Are we done?
No, not that.
Why? Isn't this fun? You guys love radicals. You can reduce 6/12, can't you? Look at the 6/12. 1/2, right? 6 goes into 12 twice. You could put the 1 up there if you want. 6/12 is 1/2. You could put the 1 up there, leave it as 1 radical 3 over 2. That's probably one of the hardest problems that you guys have to do. When I have parentheses underneath the radicand, what do? You can just go ahead and perform the mathematical operation. 15 plus 21, 36, square root of 36, 6. that should give you enough to finish the entire worksheet. And I do believe 9.2's worksheet you know how to do now. It's even got some variables on there. So, guess what you guys get to do? That's right. Finish 9.1 and do 9.2. That'll probably take us through tomorrow and Thursday. So I can make up another quiz for Friday. Boy, you guys are right on top of things. That is great. And you spit out the answers even before I get them out. Questions, comments, concerns? Sometimes it feels like I'm just talking to myself.
Don't cry.
Oh.